Molecules of gas inside a closed container of constant volume. What happens to the molecules of the gas when the container is heated?
D.
They move faster, they heat the container wall with less force, they get closer together, no, they expand. Okay. Yeah, the answer is between A and D. You go with D, right?
Yeah.
Correct. Now we go to the next one. I gave you smoke particle heat by air molecule. I was using that to explain to you the Brownian motion. So let's try this question. When a microscope is used to look at smoke particle in air, Brownian motion is observed. What causes the smoke particle to move at random?
A.
The smoke particles are hit by air molecule. Yeah, correct. Now, which change is evaporation? From where to where is called evaporation? Look at this diagram.
C.
From gas
Wait.
to
Hold
liquid.
on. No, liquid to gas.
Yeah. Right?
Sorry, B. Sorry, I didn't see that.
Correct.
It's the same question.
Yeah, they repeated this one. Okay, let's go to another one.
Ika Allah anway.
They got you good. Okay, let's see this question.
I don't know.
The diagram shows a metal foot bridge. A metal foot bridge located in the Sahara Desert, where the temperature is much less at night than during the
Wait,
day.
I can't see the question.
Huh? You can see it?
I can't see the question. No.
You cannot see it?
No.
Okay, wait, let's reshare. Can you see now?
Okay, I can see that.
Okay.
Yeah.
He said the diagram shows a metal foot bridge located in the Sahara Desert, where the temperature is much less at night during the day. Now the ends of the bridge are firmly fixed to the sides of the narrow valley. Okay, the solid line shows the bridge during the coldest part of the night. The solid line shows the bridge during the coldest part of the night. Which dotted line shows the bridge at the hottest part of the day? Which it will expand.
No.
During the day it will expand because it's a metal foot bridge. It's a metal, so metal will expand when heated. So during the day, Sahara Desert is super hot. So during the day it will expand. Will it expand downwards or will it expand upward? Your answer is
Upward.
Huh? So
Upward?
you go with A?
I don't.
Yeah. You scared?
Oh, okay.
It will expand during the day very high. At night it reduces. You see the thick one for night is also upward. If this thick one was downward, was drawn here, then the during the day would have been the D. Is that okay?
Yeah.
Yeah. Okay. Now a glass bottle has a metal cap. The cap fits very tightly and is difficult to remove. Now the cap and the neck of the bottle are dipped in a bowl of hot water. Now the cap can be removed more easily. What happens to allow the cap to be removed more easily from the bottle? A. The cap contracts. B. The cap expands. C. The
I
glass bottle.
think the glass bottle expands, or maybe it's either B or D.
If the glass bottle is
I did a similar question.
yeah.
I did a similar theory question, and the answer, I don't know what the question was, but the answer was the glass expands. So
Okay.
I'm not sure.
Okay, let's go through this question
Or
again.
it was an insulator. I don't know.
Let's go through this question again. A glass bottle has a metal cap, right?
Yeah.
Now, the cap fits very tightly and is difficult to remove. The cap and the neck of the bottle are dipped in a bowl of hot water. The cap can be removed more easily. What happens to allow the cap to be removed more easily from the bottle? The cap contracts, the cap expands, the glass bottle contracts, the glass bottle expands. You know, expansion will make it big, the glass bottle bigger. So if it expands, you cannot remove the you cannot remove the cap. It's only when it contracts that you can remove, right?
Oh yeah.
Okay,
Makes sense.
you can say the cap itself expand,
Yeah.
or the
I
bottle.
got it now.
Yeah, the cap itself expand, meaning it get wider, so it's able to easily leave.
Yeah.
You understand?
Yes.
Okay, another question. Now, it said the temperature of a bridge rises from 5 degrees Celsius on a cold night to 25 degrees Celsius at midday. So, what happens to the bridge? It becomes heavier, it becomes more dense,
It becomes more dense.
its length increases, its mass increases. It becomes more
Wait,
dense.
the temperature
Are you sure?
rises. No.
When things are hotter, they don't become denser.
Yeah. When they're cold, they're dense. They
Yes,
become
yes,
dense.
yes. The answer is between C and D. In fact, D is wrong.
Why? What? How? What does the length have to do with?
Yeah, because when things expand, you know, when temperature increases, then the bridge expands, right? When things expand, their length will increase, especially if it's linear expansion.
Okay.
If it's linear expansion, when heat is supplied, then the bridge will increase in length.
Okay, got it.
Yeah, C. Okay, let's see this question. Okay, equal masses of two different liquids are put into identical beaker. Right? Are you there?
I can't see the question.
You can see?
The question. I can't see it.
Okay, wait, let's reshare. Can you see now?
Yes.
Okay, the question says equal masses of two different liquids are put into identical beakers. Equal masses of two different liquids are put into identical beakers. Liquid 1 is heated for 100 seconds and liquid 2 is heated for 200 seconds by heater of the same power. Each liquid has the same rise in temperature. Each liquid has the same rise in temperature. Now here is the one for liquid 1. Look at the heater here. The heating time is 100 seconds. So the heating time is 200 seconds.
I think it's D.
Okay, the thermal capacity of liquid 1 is less than the thermal capacity of liquid 2. Yes. Each beaker of the liquid has the same thermal capacity. No, they don't have the same. A is wrong. Each beaker of the liquid receives the same amount of energy. No, because energy is IVT. Energy is I, that's current times voltage times time. So this one has a bigger time, therefore it has bigger energy. They don't have the same energy. So B is wrong. Liquid 1 receives more energy than liquid 2. That's wrong. Liquid 1 does not receive more energy because energy is what? IVT. Energy is electrical energy by the heater is IVT. Your current times your voltage times your time. So since liquid 2 has 200 seconds, is bigger than liquid 1. Liquid 1 is 100 seconds. So therefore the liquid 1 does not have more energy if they have the same current and voltage, because remember they say the heater is giving them the same power. You know, power is IV. So they both have same equal power. Power is IV, current times voltage. So both of them are being supplied with same power. So power is constant, IV is constant. So the difference, what determines it is the time. So liquid 1 does not have, liquid 1 receive more energy than 2 is wrong. Then the thermal capacity of liquid 1 is less than the thermal capacity of liquid. Yes. That's thermal capacity is less. Yes. D. Now we go to the next one. They repeat the same question, right?
Yeah, it's the same one.
Wait. They're doing good. Right? Let's go to another one. Repeat this. Are you sure it's exactly the same?
Yeah, it's the same. It's the same.
I think they were sleepy.
I don't know.
Okay, say another one. It is a warm and humid day. A glass contains an iced drink. Water start to form on the outside of the glass.
Condensation.
Condensation. Ooh. Ooh, clap for yourself, man. Okay, let's go to the next one. Let's see this one.
I think. Hold on. Because I came across this question.
Okay. A copper bar and a woody bar are joined.
It's D.
Okay, let's go through it together. A copper bar and a woody bar are joined. A piece of paper is wrapped tightly around the joint. A piece of paper is wrapped roundly around the joint. Now the bar is heated strongly at the center for a short time, and the paper goes brown on one side only. The paper goes brown on one side only. Which side goes brown, and what does this show about the wood and the copper? You say it's D. Brown side is wood, and then the wood is an insulator, and the copper is a conductor. The brown side, this one say brown side is copper, wood is a conductor. No, this one is wrong. Copper is also, so this one is kicked out. Brown side is copper is insulator, No, it's a wood is insulator, copper is a conductor. So B, my contest for answer. Let's go to C. The wood, the brown side is a wood. Wood is a conductor. C is wrong. Wood is not a conductor. So the answer is between B and D. So let's go through D again. The brown side is the wood. Wood is an insulator, and copper is a conductor. Yup. Okay, so that's correct. Now let's see this one. This is like a heated curve. This is a heated curve. We say a solid substance is heated at a constant rate, and then the solid changes into liquid and then into a gas. A solid substance is heated at a constant rate. The solid changes into liquid and then into a gas. Now the graph shows how the temperature of the substance changes. Now what is the melting point and what is the boiling point of the substance? You want to tell the melting point and the boiling point? Super.
Yeah, I'm thinking. Hold on.
Super easy.
Is it D?
No, you're close.
Is it C?
Yup. You know the
Why is it not C? Because 700 is a boiling point, and then it'll turn into gas. Because there's. Wait, I'm so confused.
Okay, wait, let me tell you. Don't be confused. Here, the substance is a solid between 200 to 300. Then, when you have a constant, at 300, you have a constant temperature. That is where melting is taking place. Melting.
Yeah, I knew that. I knew it was either C or D because the constant temperature.
Yeah.
I knew that, but
yeah, the constant temperature is the melting point. Now, this first constant temperature is your melting point. And after it has melted, it changes to liquid from 300 degree to 500 degree. That's liquid. Then at 500 is having another constant temperature. That's the boiling point, 500 degree. So beyond 500 is now a gas. It's now a gas completely. Beyond 500, from 500 to 700 is now a gas. So, but when they're asking of melting point and boiling point, is 300 and 500. These constant values. Is that okay? C.
oh,
Is that okay? C.
yeah.
Okay. So let's see this one. This is what we've done before, right? The Yungud.
Yeah.
The Yungud. Now this one. All these are past IGCSE questions, you know, right?
Yes.
Okay, let's see this one.
It's B.
You've read it?
No, I just honestly I don't really read it. I just looked at the temperature and it looked constant, so I thought melting.
Okay, let's go through it. Let's read it. A glass of water is taken out of a refrigerator. Several ice cubes are put into the glass of water. Right? The glass is then left in the room for several hours. The graph shows how the temperature of the water in the glass varies from the time it is taken out of the refrigerator. So we have the temperature, we have the time as is. What does the temperature mark S represent? Temperature mark X. The boiling point of water, the melting point of ice, the room temperature, the temperature inside the refrigerator. You said
Hold on, it's either B or C.
B or C?
Yeah. It can't be D because it says it's left in the room for several hours.
If you have,
It's C, right?
yeah, if you stick to
Oh,
C, you would
okay.
have been super correct. The room temperature. Okay, you said B or C, right?
First I said B, yeah.
Okay, you are still correct, but the right answer
But
is
then after I read the question, I thought C.
okay. The right answer is Yugo Shoko. Yugo Shoko C, room temperature. Now let's see this one. Ah, they bring the same. They're Yungu, right?
Mm.
Let's see this one. Read. Don't just give me the answer. Read. Can you? If you cannot say I read.
No, I can see.
Okay.
When they say radiate, do they mean that it lets the thermal energy like pass through, like the
Yeah.
heat
Yeah.
and
Give it
pass?
out. Give it out. Yeah.
Uh, I think it's now white. It kind of like blocks. What did I say? It reflects. What did I say?
Huh?
I studied it, but I think it's black. But I'm not sure. Is it dull or shiny? Was it radiates? Radiates? Oh. Is it D?
The plate that which one we radiate thermal energy at the greatest rate, right?
Mhm. Oh, A. Okay.
Now, which is plate A? The plate that is dull and black. Okay. Do you know why uh, we say
I
that?
knew it was black, but I didn't know if it was dull or shiny. I don't know.
Yeah. That's why in the hot place, like the Middle East, the black, absorbs a lot of heat and also radiates a lot of heat. Emits a lot of heat.
That's why the houses are always white,
Yeah.
or they don't. You don't see a house that's black.
Yeah. Okay, that's super great. Super great. In fact, that's why some people they prefer their cars to be white
Yeah.
in very hot countries. But if it's very cold country, it's better to have black cars.
Yes.
Okay. Now let's see the first one again, just one more time. Yeah. They ask you for the equations, the relationship between. They say a block of ice is uh, removed from a freezer. Some of the ice melts to produce water. Some of the water that is produced evaporates, and the original mass of the ice is P. Then the mass of the ice that has not yet melted is Q, and then the mass of the water is R. Now the mass of the water vapor is S. Now the diagram shows these changes. Before melting is the mass of the ice with P, and then after it has melted, some unmelted one remains here, and then which is Q, and then you have mass of water R and mass of the water vapor. So P will be equal to, you can see this arrow is showing that this P is equal to Q plus R plus S. That's why this answer is a B. That's why this answer is a B. So we just quickly look at the first two.
Why are we repeating the questions again?
For clarity.
Oh, okay.
Yeah, for clarity. For Brownian motion, I think you got this. You say smoke particles are hit by air molecule. A. That's super correct. Okay, I think we're done with these questions, right? Is there any other one?
You can scroll down. There's page 1 and then page 2, if you can see.
Okay,
yes.
yeah.
Down.
Yeah, yes.
Yeah. There's a lot of questions on this thermal physics.
Okay. This is very long. You want to try?
Yeah.
It's a hollow aluminum cube is filled with very hot water. a hollow aluminum cube is filled with very hot water. Side X of the cube is opposite side Y. Side X, a hollow aluminum cube is filled with very hot water. Side X of the cube is opposite side Y, right, of the cube. One of these two sides is black and one is white. A student holds the back of a student holds the back of one hand 5 centimeters from side X, and then immediately holds the back of the other hands 5 centimeters from side Y. So he's using his hand to feel the heat. Okay, very hot water is inside this hollow aluminum cube. And the hand's head near side Y feels warmer than the hand head near side X. Right? Now, which rows identify the black side and correctly compares the rate of emissions of thermal radiation from each side?
Wait, hold on. Just to clarify something, white usually doesn't absorb the heat. It kind of reflects it, right?
Which one?
White in general.
Yes.
So that means
more or less reflects it. It's not a good absorber, and neither is it a good emitter.
Emitter,
it's not a good. It's not a good radiant of the energy, of the heat energy, but it's a very good.
But then, what does it do with the heat if it doesn't emit it? If white doesn't absorb it and it doesn't emit it, what does it do with the heat?
It reflects it mostly. That's its biggest characteristics.
So they said here, inside Y, it feels warmer than the hand held in near side X. First, before I read this, I thought, okay, it probably is inside X. But then when they said the hand held near side Y feels warmer, then that means white is inside Y.
Okay, wait. Let's see. Did they mention what is Y? The part of the Y? He said the hand head near Y.
No, we're supposed to find out.
The hand head near Y feels warmer than the hand head near side X, right? Now, which rows identify the black sides and correctly compares the rate of emissions of thermal radiation from each side? So, which one would be Y now? The black side will be Y, right?
Yeah, it'll be white because it kind of reflects it. But if it was...
No, you said the hand head near side Y feels warmer, right?
Yes, so it'll be white. Wait, which are we're supposed to choose the black side?
They're talking about the black side, right? So we are choosing the black side.
Then the black side will be X.
Because black side will be X.
Because X absorbs it, but then Y reflects it, so the hand will feel the heat.
Yes.
Right?
Yes. So the black side will be X, correct? Because the hand that will feel warmer is the one that where the heat is being reflected, right?
Yeah.
So X will be the black side. So what is the rate of emission of the thermal radiation? The rate of emission greater for X, the same for X and Y?
It's either A or B.
Yeah, it's greater for X, right?
I think so.
Yeah, it's greater for X. Oh, the question threw us out.
Oh, this question is so confusing.
No, it threw us out. Now it's saying that the black side is Y. And what did they describe here? He said the hand that head near the side Y feels warmer than the hand that was head near the X. So if the hand
I
that is,
understand. I understand that black absorbs the heat. I understand that. But what does the white, like in general, ignoring this question, what does the white do with the heat if it reflects it?
yet that, when you reflect the heat, then definitely this one will feel uh, hotter or warmer.
Yeah.
But this material itself, did they describe what it is? It says
They
student
said it's aluminium.
holds the back of one. Is that where it started from? No.
It's aluminium. Oh, maybe aluminium.
Side X of it.
Okay.
A hollow
It's
aluminum
probably,
cube is filled with very
yeah.
hot water. Okay.
Is it because of aluminium?
Yeah. A hollow aluminum cube is
Mm.
filled with very hot water. Side X of the cube is opposite side Y of the cube. One of the two sides is black and the other one is white. A student holds the back of hand 5 centimeter of one hand 5 centimeter from side X, and then immediately holds the back of the other hand 5 centimeter from Y. Okay. Now the hand that is held near Y feels warmer than the hand that is held near the X. Now which row identifies the black side and correctly compares the rate of emission of thermal radiation from each side? Okay, because blacks, they are good, they are better absorber of heat and better emitter of heat. Then
Oh,
why,
okay.
since Y feels warmer, Y is the black, is the black side.
Yes, I got it now.
Yeah,
Okay.
it's not
I
because of
understand.
reflection. It's not because of reflection that is making it hotter. Because blacks are good absorber, at the same time they are good emitter of the heat energy. So the one that feels warmer, that side is where the black is.
Yeah, got it.
And if that is so, then the rate of emission of thermal radiation is greater for Y. Is that okay?
Okay, I will never forget this question.
Yeah, the
If they
question.
bring it on the exam, I will know the answer
Yeah,
straight away.
yeah. It's not even confusing. It's just we are careless. Is that okay?
No, I was just confused because the white reflects. So I was like, where does it take? Like, where does the heat go if it reflects?
Yeah, I get it. Okay, try this one. Which types of thermal energy transfer requires a medium?
What do they mean? Medium, like a device,
To
or
Yeah, to pass the heat.
I have
One
no
of them
idea.
does not require a medium.
Is it conduction, convection?
You.
Yeah. Okay.
Yeah. Conduction and convection. Radiation does not require a medium. Can move through a vacuum. Okay? It does not require. Okay, this one. 4 different liquids are poured into 4 containers. The diagram shows the depth of the density of the liquid in each container. The diagram shows the depth of the density of the liquid in each container. In which container is the pressure of its base the greatest? So they have their density, right? They've given you density in gram per centimeter cube of this one 3.1, this one is 1.2, and this one is 1.3, and this one is 0.8. What you need to know, pressure, the relationship between pressure and density. Relationship between pressure and density. Okay, the relationship between pressure and density. Pressure in a liquid P is equal to rho GH. This U is density. So pressure will be greater with decreased density. So gravity is constant. There, the two factors that will be considered is the depth and the density. So if something has a greater density and with a bigger height, then it has a greater pressure. So these are the two factors that contribute to the pressure greatly. Now let's see. It says 4 different liquids are poured into four containers. The diagram shows the depth and the density of each of the liquid in each container. So the depth is the height, and the density. These are the two factors that determines the pressure. Now, in which container is the pressure on its base the greatest? So there's going to be a dichotomy. So, or if, on the contrary, you can just slot it for each one. 3.1 times 10 times 10 for this one. You can find the pressure of each one. This one is 3.1 times 10, which is the value of the G, gravity, times 10, which is the value of height. So if you do this, 31 times 10 will be 310, whatever. That's the P1, the first pressure. Let's do for the second one. The second one will be 1.2 times 10 times 20. 1.2 times 10 times 20. 1.2 times 10 times 20. So 1.2 times 10 is 12. 12 times 2, 24. That's 240. This one will be 240 if I'm not mistaken. Right? The P3 1.3 times 10 times 30. 1.3 times 10 times 30. Is it 30? This is like 30. 30 times 3. 30 times 2 is 26. Times 3, 39, right? So 39, that's 390. So this is 390. The P for the last one. The last one, we have 0.8 times 10 times 40. So we have 0.8 times 10 times 40. 0.8 times 10 times 40. 0.8 times 10 is 8. 8 times 4 is 32. So we have 320. So which one has the greatest pressure? This one. Right? 390 is the greatest. That's the third one. The third one has the greatest pressure. This one. C.
Yeah. Can you send me the working for it on WhatsApp?
Okay. Okay. I snap it or share the link.
Yeah. Sir, it's already 7 o'clock and I have a class after this, so...
Okay. Yeah, it's already past 12 here. Okay, we stop here, right?
Yes. I might need help with the calculations, like for a specific heat capacity, because some of these questions are kind of confusing.